Welcome back to Scaling Sustainability Impact. This is episode 2 of our conversation covering AI for sustainability. In this episode, Eryn Devola and Pina Schlombs discuss industrial-grade AI, how AI supports circularity, and how companies can begin integrating AI solutions into their operations. We hope you enjoy the show. It's awesome to hear both of you so passionate and excited about this topic and to see how much potential there is with developments in AI specifically for sustainability. But what kinds of AI are essential for these industrial environments? And how does Siemens make sure its AI solutions are optimized for these demanding settings you're both talking about?
Maybe I can take this one first. Where we see what is very crucial in the industrial space is that we call it applying industrial grade AI. And industrial grade AI really needs precision. And what does that mean for our understanding and how we apply it? It means it needs three key characteristics. So the first one being trustworthiness. What does it mean? It means that we need to understand the data and their sources that are used to feeding and training the models. We also need to understand how biases work in the industrial space. There are biases, but they're different to the consumer space where we are more used to using AI, right? So there are even biases against different machines depending on what the data of the training model might have looked like. So correcting for that is a very crucial element of making it more usable as the output. The second characteristic is the accuracy. So that means that the answer that it gives us actually matches the real world, right? So since everything that we do, we're using the digital world, right, to make the real world better, it needs to match in the output the real world as best as possible. And that's where the accuracy comes in. The last and third one is reliability. Now, having worked with AI, people would understand that if you ask it the same question over and over again, it might give you different answers. And this is actually a phenomenon that in the industrial space is not very helpful. So we need to employ measures to correct for that or mitigate these kinds of behaviors of models. So trustworthiness, accuracy, reliability are really like the key characteristics of industrial grade AI. And one other thing that I think makes industrial grade AI really so powerful is that we can feed it all the domain expertise that we have in the industrial space, right? We've been talking about engineering, we've been talking about production, we've been talking about supply chains, all very specific industry domains and expertise. And all of that can be fed into the model so that they specifically understand and specifically can help us in these domains. And we can even, not only we've been talking or hearing a lot about like large language models, right? But we don't often need like the large language models. Sometimes we can very much deploy like small language models, right? Right sizing as a keyword here to the task at hand. So that also the impact of inference that we have with the training and using of the models is minimized. And then lastly, I would say that looking forward, I'm very curious to see and very excited to see how agentic AI is going to transform and take us really to the next level and giving us really the agency, flexibility, but also the speed of having expert domain agents specialized in their fields, orchestrated by humans to really get us a jump ahead in the speed and scale of how we can deploy and leverage the results of use of AI.
So I want to circle back to the circularity and circular economy topic for a moment, no pun intended. But we are seeing companies realize that the potential for circularity to be a profit driver in addition to an enabler for sustainability. How do you see AI enabling greater circularity in industrial operations? And I think, Eryn, you can get us going with this one.
I mean, I think the first thing to always recognize is if we look across the planet, we have few regions with really abundant resources, and we have a ton of regions with really abundant waste. So how do we turn the waste of today into the products of tomorrow while also making the products of tomorrow last longer? And as Pina said at the beginning, make sure we've got a plan for that next life of that product of how do I disassemble it? How do I repurpose it? How do I replace as little as possible in that particular process. And really, what it reminds me of so much is the manufacturing philosophy. I didn't mention this earlier, but I love factories. I grew up in factories, and we've been working in that space for so long to eliminate waste, to work toward a lean program. And for me, circularity is really just the next level of lean, and really looking at any type of waste you have in your production or in your product as a design flaw that we should be addressing with that 80% up front. And so this is where we kind of go back to what Pina was saying about how important AI is to get us to design the right product in the right way, so that it's easy to manufacture, easy to use in operation, and then easy to redeploy at the end of its first useful life. And so this is where I really see AI as being a significant tool there. And if we look at products we've already produced, this is actually where I think AI might have a great way for us to turn some of that waste into into more usable products. So often products are removed from service because they aren't in fashion anymore in the consumer side, because maybe an entire production line is no longer going to be used, but there's components in there that still have quite a bit of useful life left. And we can use AI to help us evaluate those products for how much life is left, and then help us better streamline the specific repair or upgrade that would be needed to return that to a full lifetime of service. So I see a lot of, again, AI as a way to manage the ongoing complexity of the work outlaid in front of them. And Pina, I'm sure you've got some great examples or some great things to add here as well.
Yeah, no, absolutely. I think just picking up on the last point you made there, is just figuring out, right, when we get products back that maybe have ended their first useful life, and then figuring out, okay, what are the best R strategies we could employ, right? Balancing the effort we need to put in to make them valuable again for a next life, to, okay, what value can they create for us in that next life cycle, and then deciding, okay, this is the route we're going to take, right? Because that's actually closing the loop here again to the engineering space, right? I mean, that next life, and would it be reuse, would it be repair, remanufacturing, recycling? There are so many options, but we've not classically been trained to look at them and also be able to evaluate, okay, at which stage of a product would which kind of our strategy be most useful to us, right? And this is again where we can leverage AI in closing also the loop back to engineering, and then deciding, okay, what strategies are we going to deploy? And I think just taking an example from the Siemens world, Siemens Energy is actually, I think, one of the great examples where, I mean, these gas turbines that they produce, right, they're powerful products that have a huge material value also inherent to them, great engineering expertise that flows into them. So you want to be keeping them alive for as long as possible, right? And what I find interesting in the projects that we've been doing with them is when they take these huge gas turbines back, they can actually employ analysis technologies on determining which blades are still healthy, or where there might be fissures in that might not be visible to the naked eye, but can be detected using X-rays or other technologies, and then be able to determine, okay, with this kind of defect, employ our strategy X, right? So they have been doing additive manufacturing for these kinds of defects is actually more helpful or more valuable than basically breaking down the whole thing and exchanging one blade, right? So that can actually minimize the efforts that you need to be taking to extend a lifetime and repair a complex product such as a gas turbine, and using the conversions of different technologies. And this is really what I think is fascinating here. What they've done is basically taking a comprehensive digital twin, the full understanding of, okay, this is how this product is made. This is how a 3D model with all its characteristics, all its specifications looks like. Then the understanding, okay, well, this is the status, the health status that it comes back with. And then to be able to analyze and determine, well, to get it back to health, well, these are the technologies that we need to employ and operations we need to do to be able to be useful again. And so multiple different technologies coming together here, as I said, from digital twins, multi-physics simulations, AI, right, powered into that, and additive manufacturing coming together to be able to extend the life of such a big product here from our own Siemens family.
One other example from our Siemens family, one of the factories we have within our DI portfolio in Firth, there we have a bit of a mixed model where we make a lot of products in the same facility, and we've been able to then extend. We've got on-site repair. We're extending that to do that life cycle extension in the same facility where you're doing new product creation. And we're doing that now for over 310 products and growing that by the end of 26 to 2000. So again, it opens up a whole world for us when we can do remanufacturing and repair to products and redeploy them at really a lower impact and therefore a lower cost by reusing those things that may have looked like waste to us, 10 short years ago.
Yeah, and Pina, you mentioned something earlier that AI allows us to see into the future, and it can be a really great tool for that. So, in your opinion, what is the best way for businesses to begin integrating AI into their operations, and where can they expect to see the largest sustainability gains, whether that be in the long term or in the short term?
Yes, maybe I can start us off with here. So there are, I would say, like 4 or 5 main steps that I would see companies should follow. So the first one clearly is, and this is actually sounds trivial, but gets jumped over a lot, that I see is clearly defining what you want to achieve with applying AI, right? And then start small and scale, right? Once you have determined what your goals are, within that, find one that is small enough for you to start with where you are at today. And then also reuse with pride, reuse existing capabilities that are there today, expertise, know-how that you already have. You might be surprised. There are so many colleagues that I have who've been tinkering with AI just in their own time, in their private life, right? Tap into that potential that you have there in the people on your teams, and let them use them for use cases that you've together defined as being useful for your goals. And then I will say build the base. So really ensure that you have the data that you need in the right quality that you need it at to feed the models to achieve the goals that you set out in the beginning. And this is a point where I see really a differentiation in the speed that companies are able to adopt and deploy AI. Is companies are very enthusiastic to start with AI because, of course, all the promises that we hear are very tempting. But then they see that, okay, well, there is a certain digital maturity that is needed, a certain databases to actually leverage AI from that base. So this is something that I would also look into. Where do we find the use cases to start with? And do we actually have the data in that space to employ AI effectively? And then lastly, I would say really foster a culture of exploration. So get people to explore using AI, gain experience, and then skill up, reskill, and educate people in a broader scale, but make it in a way that they can get to know this new and powerful technology that for some might seem daunting, for others is super exciting, in a playful way. Let them explore, and then also let them find new ways of doing things that they have done classically, maybe on a day-to-day that they thought mundane, and now can use an AI companion, a co-pilot to fly with them.
So, Pina, you talked about how important it is to build that base with data, and companies now have more access to data than ever, and that presents both an opportunity and a challenge. So how should they determine that quality data? And I know you mentioned use cases, but do you have any specific examples of that?
Yeah, sure. So I see a couple of points that companies should be looking at in determining the right quality of data. And I don't think that we have a lack of data per se in the industry. It's just that like 80% is not used today. So we're gathering tons of data every day, but not making use of the most of it. So a couple of points in how I see companies determining data quality. So the first one would be actually defining what data quality dimensions are relevant for your company in your domain. So that could be establishing clear criteria such as like accuracy, we talked about that before, completeness, consistency, validity, timeliness, uniqueness, integrity, reliability, and relevance. Now, the next step I would encourage companies to do is what is called data profiling. So using automated tools to analyze data for patterns, anomalies, and inconsistencies. And this really helps in identifying areas that needs improvement. Also use like manual reviews, like step by step, to ensure that the processes you're implementing actually meet the goals or the standards for quality that you've set out in the beginning. And then also what a lot of companies need to do is data cleaning. So you might have tons of data, but they're not useful to be deployed for AI purposes. And implementing processes that help you not only identify where you need to correct, remove incomplete or inaccurate data, and automate that would be a very good way to start building that base of data that I talked about earlier. Do regular audits, really ensure that also with your day-to-day operations, the data standard that you might have established at some point does not get diluted down the line. And then last, I would say, establish a data governance, right? If you don't have it already as part of your data strategy, establish a framework that includes the policies of how to not only gather data, but also how to ensure that you have the right data that you can trust and actually make decisions on, right? Because that's what we want to be able to do in the end, that we can have confidence in the decisions that we can take with the data that we're leveraging here. So those would be the main points I see and would encourage companies to take into consideration when looking into the quality of data.
That's a wrap on episode 2 of AI for Sustainability. Thanks so much for listening, and stay tuned for our final episode in this series, coming soon.